Chapter 8 Quadrilaterals. You know what happens when we join 3 points? We get a triangle. Now let's see what happens when we take 4 points. In the first case, we will take all the 4 points to be collinear points. Collinear points are those points which lie along the same line. So, when we join 4 collinear points, we get a line segment. Now, we will again take 4 points, but this time only 3 of them would be collinear. So, these 3 collinear points form a line segment. And the fourth point is somewhere around here. Now, this fourth point, when joined to the end of the line segment, we get a triangle. And now, we won't take any of the 4 points to be collinear. Let's see what happens. Here, we get a different figure which is called a quadrilateral. A quadrilateral is a figure formed by joining 4 points in an order. Now, I am making a quadrilateral. We will name this quadrilateral A, B, C, D. A, B, C, and D. Every quadrilateral has 4 vertices. Vertices of a quadrilateral are its corners. So here, in this quadrilateral, its vertices are point A, point B, point C, and point D. And a quadrilateral also has 4 sides. The sides of a quadrilateral are its edges. So here, the 4 sides are side AB, side BC, side CD, and side DA. And a quadrilateral also has 4 angles. By 4 angles, we generally mean the internal angle. So, in this quadrilateral, the 4 angles are angle A, angle B, angle C, and as you know, angle D. Now let's draw this quadrilateral ABC, ABCD again. This is quadrilateral A, B, C, D. Now, let's join A to C. And B to D. You see, I have drawn here 2 line segments. These 2 line segments which join the opposite corners of the quadrilateral are called its diagonals. So, as you can see here, a quadrilateral has 2 diagonals. By now, you have a general idea of a quadrilateral. Now let's talk more about different types of quadrilaterals. So let's come to this figure. This is a trapezium. A trapezium is a quadrilateral in which one pair of opposite sides are parallel. Here you see I've drawn two arrows. These two arrows indicate that these two sides are parallel. This is a trapezium. Let's come to the next figure. This is a parallelogram. In a parallelogram, both pairs of opposite sides are parallel. So this side is parallel to this side and this side is parallel to this side. Also, both these opposite pairs are equal in length. So these two sides are equal and these two sides are also equal. Now let's come to the next figure, which is a rectangle. A rectangle is a special case of a parallelogram. A rectangle is a parallelogram in which all the angles are equal to 90 degrees. So, as you see, this angle is 90 degrees. Similarly, all these three angles will be 90 degrees. Now let's come to our next figure, which is rhombus. A rhombus is a quadrilateral who is actually also a parallelogram. The more special feature of rhombus is that all of its sides are equal. So here you see all these sides are equal in length. This is a rhombus. Now the next figure is a square. A square can also be called as a parallelogram, a rectangle, a rhombus. Its special property is that all of the angles are equal to 90 degree and all its sides are equal as well. You can call it as a parallelogram because you see both pairs of opposite sides are parallel and equal in length. And you may call it a rectangle because all of its angles are 90 degree. And just like rhombus, all the sides of a square are equal in length. So a square is a special case of a parallelogram. In fact, you see that parallelogram, rectangle, a rhombus and a square, all these quadrilaterals are special cases of a trapezium because in all these quadrilaterals at least one pair of opposite sides is parallel in length. Now we come to a last figure, which is a kite. In a kite, the adjacent sides are equal. Not all adjacent sides. Here you see this side is equal to this side, but this is not equal to this side. Similarly, these two sides are equal in length. A kite cannot be called as a parallelogram. Now let's talk about a very interesting fact, which is that the area of a rectangle is greater than the area of a parallelogram, both having the same perimeter. Here you see the perimeter of this rectangle is 5 plus 4 9 into 2 18. Similarly, the perimeter of this parallelogram having the sides equal to 5 cm and 4 cm is also 18. Now let's talk about their areas. The area of this rectangle is equal to 5 into 4 is equal to 20 centimeters square. And the area of this parallelogram is not equal to 20 centimeters squares because the area of a parallelogram is equal to the base into its height, which is CD into BE. Here, the area of the rectangle was AD into CD. AD into CD. Here you can easily see that AD is greater than BE. AD is greater than BE, which tells us that AD into CD would be greater than CD into BE. Therefore, area of this rectangle will be greater than the area of this parallelogram, even though both have the same perimeter.